May I please welcome Mr. Ameya Nalavde, Head India, Heraeus Noblelight, who will be delivering his deep insights on the complementary infrared and UV solutions for battery manufacturing. May I please welcome Mr. Nalavde to please come up on the dais.
Morning, everyone. Hope you can hear me. First of all, thank you for being here. I know it's day 3. It's hard to stick around until day 3, so again, appreciate your time for being here. My name is Ameya Nalavde, and I'll be talking about today how we can help you with our infrared and UV curing technology to get your battery manufacturing processes more efficient. We have a large team of people who are dedicated to the battery. So again, if you are in your development phase, we can definitely help you develop your solutions. Let's get started. So the agenda for today, first, just a quick overview about the business, what offerings we have in the battery solution, and then go over some of the applications that we have proven in the battery sector. First, let's start about the company. So Heraeus, they are a German-based company, more than 17,000 employees spread all over the world. One of the largest family-owned companies. They've been set up in 18th century. So it's been, they've been in business for a long time. They're a portfolio company, so they do everything from, precious metal trading to medical components to the sensors. But the division where we fit in is the lighting division, and that's where we make the UV as well as the IR curing systems. So some of the product offerings, so we are a lighting company. So as I said, we do everything from UV to IR. So when you talk about the UV, typically people know about UV from, doing your disinfection, whether that's water disinfection, your surface disinfection, also air disinfection, right? So during the COVID time, everybody, we saw these room cleaning, the purifying the air with UV disinfection. So that's something people know about UV. But we also provide UV equipment for the industrial curing purpose. So that's where you're talking about, drying your inks, drying your coatings, drying your adhesives. That's what we do. Other products, we also do the analytical lamp. So when you talk about the analytical lamp, that's your spectroscopy. So in the lab, you are using these lamps to, to doing your measurements. We also provide the lamps for the, your high performance liquid chromatography. We have flash solution, and then at the last, the infrared solution. And when we talk about infrared, compared to your traditional conduction or your convection heat technology, IR is the radiation-based technology. So depending upon the application, it could be more efficient, and what we call it, it's a green technology. So anywhere where you need heat, you need to do plastic welding, you need to do plastic deburring, or you need to do baking. That's where you would use the infrared technology. And overall, we are not just a lamp technology, we also do a custom solutions. So we do the whole turnkey solution. So you talk about the light source, going to your power supply, your controls, and also designing the overall turnkey system. So that's what we do. All right, let's talk specifically about battery. So what we are doing in the battery segment. First, the lithium ion. That's the most mature segment for us. We've been in this for now many years. And when you talk about the lithium ion, so we start at the early stage. So starting with your electrode drying, we use the infrared technology. And then when you go to the cell manufacturing, or let's say cell assembly, as well as your packaging, that's where we are providing the UV curing solution. And UV curing solutions are mainly used for, the biggest benefit of doing the UV curing is to get the instantaneous, let's say, drying or the curing effect. Typically, you are doing your drying, it takes at the room temperature. You're going to take it anywhere from 5 minutes up to half an hour to hours. Whereas with the UV curing, you get the instantaneous drying. So that's one of the disadvantages, and this is the area where I'll be talking about today. We'll focus mainly on some of the applications that we do with the lithium-ion battery manufacturing. Other than lithium-ion battery, we are also doing work in the sodium-ion. This is still relatively new, upcoming technology. There are a few pilots line all over across the world. But again, over there we are using our infrared technology. And the difference between your traditional lithium ion versus sodium ion, your sodium ion, the slurry is thicker than your traditional, your cathode or anode slurry today. So you're going to need different energy density to dry it. You need to evaporate the water. So it's that's where we add the benefit, because you are treating directly to the surface, and with the radiation you're trying to get the heat out faster. Few other technologies in terms of battery, solid state fuel cell. It's still at early phase. There are some development going on. We are working with a few companies, but a lot of that is still still in the early phase, and all of that is still in the lab or development phase. So again, as I said, today we'll focus mainly on the lithium-ion battery manufacturing processes. All right, so your high-level battery manufacturing process. So at the top there, what you see circled in the squared in the orange area, that's your electrode processing. And what we do over there, we provide the infrared or the radiation heat to dry your slurry. So you are with your convection ovens, where you have the, let's say, hot air, which could be gas or oil-based ovens, you add infrared to that. And by doing infrared, you are trying to get better quality of the electrode. So that's the process we will do deep dive in. And then at the bottom, you say squared under the blue section, that's where we provide the UV curing solutions. So in that phase, starting from your wave-based application for your separator, so curing the coating on the separator, going to also your cells. So whether it is cylindrical cell or prismatic cell, you put a coating around it. So today people are doing different things. Some people do the film, they put around the cell, but there is a new technology, well, relatively new, where people are putting a coating, because coating is more efficient, because with the film you could have delamination. So coating could give you more cycles. So that's something where we provide the curing system to dry those coatings. Coming down to the filling, formation, a lot of that process involves your adhesives, involves your again, coatings, adhesives. You also have your for the battery management system, your electronics. That's where the potting, as well as conformal coating. That's where also there are UV curable coatings that we cure using our technology. Let's jump into the first process. So when we talk about electrode manufacturing, there are certain trends that are coming up right now. And again, over the 3 days, you've been hearing about this. The biggest, everybody wants to have long range. Everybody wants, cars to go, 400, 500 miles before you have to charge them. And again, that's something, one way to do it is by packing more slurry on your collector, right? So how do you do that? When you start putting, whether it is your aluminum or your copper foil, when you start putting more slurry, you're gonna get more, you're gonna get more energy density out of it. So that's the biggest trend. Another one is your energy, your energy consumption. With the war going on, as well as the prices going up for the energy, everybody is trying to do this drying process more efficiently. Because if you look at the overall cost for manufacturing the cell, almost 50% of that cost, or even more than that cost, is coming from this large oven that you use for the drying of the electrode. So that is very, not just labor intensive, but also is very, very expensive in terms of capital expenditure. Last but not the least, the demand for batteries is so huge. Everybody wants to go faster. So if you can increase the line speed by 30% or 50%, that is significant. So that's some of the places where industry is focusing. Excuse me. And you look at the technology that is being used today to dry your electrode, which is the convection oven, there are some challenges. So when you try to pack more slurry onto your collector, and if you don't have enough dwell time for drying the electrode, it's going to create problems. And the problems that you're going to have are, binder segregation. You're going to have cracking on your electrode. And how that affects is that towards the, as you go through the process, is going to if your electrode quality is not good enough, it's going to create problems later. So everyone here is talking about thermal runaway and how you could avoid that. Well, this is the root cause. You need to start at the beginning where you say, okay, let's get a better quality electrode, avoid the binder segregation, avoid the cracking, and that's how you can minimize thermal runaway eventually when there are multiple cycles, charging cycles that you do on the battery. Again, I talked about the how energy intensive this process is, and going higher speed is a challenge because these ovens are already 50 to 100 meter long. If you need to go faster, there is always a space constraint. And how do you do that? That's where we come into the picture, and we introduce our infrared technology. So some of the issues, by introducing infrared, we can get away from the binder segregation. We can have better quality or improved quality of your electrode. Also, we can increase the light speed. We have increased the speed for some of the manufacturers up to 50%, and that is very significant. And last but not the least, again, doing it using infrared, which is a direct radiation heat, you're going to save energy as well. So how do we do it? There is a lot of science behind this. We have done a lot of studies in terms of how drying process works. Again, I'm just showing here one slide, but we could go into a lot more details. Excuse me. One way you could do it is by observing how heating works at the molecular level. And typically, some of the drying application, the principle is you put more heat there, and you can get the drying effect. But that's not the case when it comes to the battery or the electrode, because you have to have, because of the chemistry of the electrode, you have to have that slow heating effect. So you can't just say, hey, put so much energy density into your ovens, and you can dry it faster. That's not how it works. Because when you start to heat it faster, and again, that's the kind of simulation you can see here. It starts evaporating water, but what it does is if you heat it too fast, you're going to have the issue where your binders are not going to have a better adhesion to your collector, and that's something you want to avoid. And by using infrared, what we have done is that we studied by heating it slowly, you can get a better quality. But by using infrared, what we are trying to do is we are trying to mimic the effects of convection heating. So you are trying to match the energy density that you have with your convection oven with the infrared. And what that does is that it's giving you, better, let's say, better finish at the end of the process. There are a few ways of doing this when it comes to whether it's your pilot line or your production lines. When you talk about the pilot lines, typically we introduce IR at the beginning of your lines. And again, a lot of these lines are not high speed. You're talking about less than 5 meter per minute lines. And that's where you are trying to mimic that. Getting the heat into it at the beginning of the process is going to get you that, avoid that delamination. And when you go to the bigger ovens, here you are talking about, here you are talking about, 50, 100 feet wide ovens. That's where we have the infrared spaced at different intervals in between your air nozzles. You are doing this via the hot air. So we place the IR heaters in between the nozzles to get the optimal effect. This is just one of the case studies. You can read through it. This was the early phase development that we did with one of the largest battery manufacturer. They are based in China. I don't think it's difficult to crack who they are, but they were having all these issues that I've been talking about, not getting the binder effect as well as getting the cracking. So we helped them, basically resolve all those issues, and we also managed to increase their speed by more than 50%. And we are working with all the other industry leaders in this too, in terms of the drying technology. All right, moving from your electrode manufacturing to the cell as well as packaging. So in this, as I discussed earlier, we have UV solutions. And here there are a lot of players who've been talking about over the last 2 days, 3 days, about how these coatings can help you avoid whether it is, thermal or structural adhesives. They've been talking about why they are useful. So I'm not going to go into that. The point I'm trying to make here is that these coatings and adhesives you can cure with UV. And by curing with UV, what is happening is that you are not waiting for that, half an hour cure speed. Most of these UV lines are automated, and what you can get out of it is, much more efficient process. You can cure it within seconds. So that's the biggest benefit here. Again, some of the UV benefits: you can do more parts compared to the traditional 6 to 10 times. You can go faster. Also, the technology we have in terms of UV curing, that's where we have what we call it microwave technology. So that is RF generated UV light. And what that does is that it gives you consistent UV light for the life of the, let's say, bulb or the light source. And that gives you consistent cured product at the end of the line. Another thing is that people look at the initial investment, the capex investment when it comes to some of these lines, but overall by doing UV curing, you are increasing your throughput, and your overall cost per part is going to be less. So that's something when you come to us, that's what we educate you about. We walk you through the process and say how you can save the money down the line. Again, same thing again. We talked about what we can do overall. You can come to us and we can help you, prove out your solution. We can walk you through it. We can do your R&D. But anyone who's looking for efficiency as well as increasing your rate of the productivity, that's where we come into the picture. So let us prove it. Don't take our word for it. Thank you.
Thank you so much, Mr. Nalavde, for sharing such an insightful presentation with us. May I please take the honor to share a small token of appreciation on behalf of Informa Markets India.